Okay, so now we'll move to the last section of this chapter in M3, acceleration varying with displacement. Okay, so in the first section, what did we focus about? In the first section, we were focused about acceleration varying with time. But over here, we are going to completely talk about acceleration varying, or acceleration is a function of displacement. Okay, so how does it work? So when we are working with acceleration as a function of displacement, basically you will get the acceleration equation with the x components. So acceleration equal to x square. So when you get equations like that, where you have a and x in relation, we can't use the normal equation we used earlier. What was the previous relationship we used? We know acceleration is equal to dv by dt. That was the equation we used previously. But those relationships, now this relationship is acceleration equals dv by dt is okay, is correct if your acceleration is a function of time. But when your acceleration is a function of displacement, what we do is we are going to slightly modify this equation. So look at the way that we modify this equation to make it relevant when you have a equation with acceleration and displacement. So what we do here is we use the chain rule and we do a small difference to this equation. Look at this. I'm going to break up this dv by dt by using the letter x. So look, dv by dt is what they've given us here, right? So I'm going to break this dv by dt by breaking it up as dv by dx. Look at this, I'm using the displacement to break it, okay? dv by dx into dx by dt. Look at this. Can you see that I've actually written the same thing but introduced a new variable, because you do realize that I still got dv by dt here. So I used the x variable to break it up. So I'm basically using this called chain rule of differentiation. Okay. So in P4, anyway, we just introduce the new variable and break the given equation. So dv by dt, I broke it with x. Okay. So then what do we know about acceleration equals? Look at this. Acceleration equals dv by dx into, are you familiar with dx by dt? Are we familiar with the person dx by dt? Yes, you should be familiar because we used this earlier. Who is dx by dt? Dx by dt is v. So you should remember this. We used this in the previous section also, right? So v is equal to dx by dt. When displacement, the rate of change of displacement with respect to time is velocity. So this is dx by dt can be replaced as v. So basically I could write here acceleration equals v dv by dx. Write it down. So this is the first equation. This is the first main equation that we use when we have acceleration as a function of displacement. So we will be working with, instead of working with acceleration equal dv by dt, we will now be working with acceleration equals v dv by dx. So this is the main equation that we'll be working, one of the main equations. Write it down. Okay, so this is the main equation that we use. Also in the textbook, they've given you the same equation another way. So you can see here, acceleration equal v dv by dx, and also they have given you another result. Can you see? They've given you that it's equal to d by dx of half v square. Let's just look at what they mean by d by dx of half v square. D by dx means what? What do you mean by d by dx? D by dx means they are asking you to differentiate what? They are asking you to differentiate half v square with respect to x. Dx means the differentiation is happening with respect to x. That's what it means. They are asking you to differentiate half v square with respect to x. Okay, so what does it give you? How do you differentiate half v square? So normally whenever you have a function with a power, what do we do? Half is a constant, leave it. How do you differentiate v square? When there's a power, you bring the power forward, right? So what happens here? When you differentiate v square, bring the power forward. So what do you get? 2v to the power 1. 2v to the power 1, right? Also, and the next thing is we differentiate with respect to x. What's the letter we have here? V. We are now, the thing is I did the differentiation here. I brought the power forward, subtracted 1 from the power, but it's a letter V. Now you know, after you're done with the power, we go and differentiate the part inside, right? Do you remember the rule in differentiation? The power is the first priority. You bring the power forward, you subtract 1 from the power, and you go in and differentiate the V. So what am I supposed to differentiate V with? I'm supposed to differentiate V with respect to X. So what is the differentiation of V with respect to X? Differentiation of V with respect to X is dV by dx. Okay, similarly, like if you had Y here, you would use dy by dx. Okay, so the thing is, when you have half V square to differentiate with respect to X, the way you differentiate this is the similar, I mean the normal differentiation, where you give the power the first priority, the power comes for, the half is staying here, the power 2 comes forward, and you subtract 1 from the power. After you are done with the power, you go in. You go in and you differentiate this V with respect to X. When you differentiate V with respect to X, you get dV by dx. So what happens here? The half and the 2 cancels out. What do we get? We get V dV by dx. Can you see this exact same value I get here? So that's what they are saying here. They are saying here acceleration is equal to V dV by dx, or it's also equal to d by dx of half V square. So mainly we can go with any of these two results. Okay, so mainly we can go with this result, or even going with this result is fine. So write down both of these proofs, because you should know that both of them are equal to acceleration. Okay. Okay, so basically at the end of the day, if the question is about acceleration given in terms of displacement, you would use acceleration as dv by dx, or you could use acceleration as the d by dx of half v square, because you saw the d by dx of half v square is the same as v dv by dx. Okay, so this is the main equation, the main equations that you need to use where when you get a question where acceleration is related with displacement. Okay, so let's go to the exercise. Okay, so let's go to the first question. Exercise 1B, question number 1. A particle P moves along the x-axis. At time t equals 0, P passes through the origin with velocity 5 meters per second in the direction of x increasing. So immediately you can see some boundary conditions are given to you. What are the boundary conditions? Exercise 1B, question number 1. What are the boundary conditions? At time 0, P passes through the origin means what? The particle passes through the origin means at time 0, x is 0, displacement is 0, with velocity 5. So meaning at the displacement 0, time 0 position, the velocity is 5. It goes in the direction of x increasing. At time t seconds, the velocity of p is v meter per second, and OP equal x. OP means, now O is the place where you start, and P. So it's moving away from the origin. So OP, P is the place where the particle is. The distance O to P is x meters. Okay, so away from the origin, the particle is moving. So OP is x meters. They've told you the acceleration of P is, can you see the difference in this particular section now? The acceleration is what? 2 plus half x. Can you see the acceleration is given with respect to what? The acceleration is given with respect to x, with respect to displacement. Okay, so it's given now with respect to displacement, not with the t variable, but it's given with the x variable. So they are saying the acceleration of p is 2 plus half x meter per second square measured in the positive x. Find v square in terms of x. Okay, your task is to find v square in terms of x. Okay, so how do we do this? The first thing that you do here is you need to realize, okay, acceleration is given as a function of displacement. So if acceleration is given as a function of displacement, what do we use for the acceleration? What do we use for acceleration? We will use acceleration is v dv by dx. Can you see? I will use acceleration as v dv by dx. So let's use it. So instead of acceleration, I will use, instead of this acceleration, v dv by dx. Are you with me? So v dv by dx is equal to 2 plus half x. V dv by dx is equal to 2 plus half x. Are you with me? And now what we do here is, I'm trying to get the v equation with respect to x. So what you do now here is, the next step is we separate the variables, meaning I'll take the dx. Can you see here the dx? We'll take the dx to the side with the x term. So you can see the right side is the side where you have the x terms, right? So let's remove the dx to the other side. What do I get here? V times V times dv. V times dv equals, on the other side I get 2 plus half x into the dx comes here. The dx comes to the other side. Are you with me? The dx comes to the other side with 2 plus half x. Over here I have v times dv. So what does this tell you here now? Over here you have the variable v, and over here you have dv. Here you have 2 plus half x with respect to x. So you can see the variables are nicely separated. You can see the v term is there in the side with dv, and the x terms are there in the side with dx. And now what do we do? Once you have it nicely separated, the v terms and the x terms, you integrate both sides. You integrate both sides. So this side, the integration is going to happen with respect to this side, the integration happens with respect to v. In the other side, the integration happens with respect to x. So that's why to perform this integration, you have to make sure that the variables are correctly separated, which means the x terms have to be in the dx side, the v term has to be in the dv side. Okay, then so after you come to this point, now it's time to integrate. So what happens when you integrate a v with respect to v? You integrate the variable v. How do you integrate the v with respect to v? The integration means you add 1 to the power, right? Integration means where you add to the power and you divide. So what do you get here? V square over 2. V square over 2 are basically the half v square. This answer, half v square. Can you see? Half v square. V square over 2 equals, this side shall be integrated with respect to x. What happens when you integrate 2 with respect to x? 2 with respect to x, when you integrate, you get 2x, right? When you integrate a constant, you know, it doesn't disappear. It becomes 2 times x. P1 integration. This is P1 integration. Okay, so plus half. What happens when you integrate x with respect to x? You get x square over 2. You add 1 to the power and divide. Is that all? When you integrate, I'm done with the integration, but you must remember to put the plus c. It is critical, it is crucial you put this plus c. Okay, you need to put the plus c because obviously they give you these boundary conditions so that you can find the plus c. Okay, right. So let's simplify this a little bit. I get here half v square equals 2x plus half into 1 over 2 is 1 over 4x square plus c. Guys, are you with me? Okay, so now they want us to find the equation for v square in terms of x. How do I get v square in terms of x? So this is where the boundaries come into play. So what are the boundaries we have? They've told us we don't have t here, but we do have x and v. So at x, when x is 0, they've told us v is 5. So use those boundaries. When x is 0, v is 5. So apply these boundaries. When x is 0, v is 5. What do I get here? Half into, when v is 5, it's half into 5 square equals 2 into 0 is 0 plus 1 over 4 into 0 square is 0 plus c. So what's the c value? C equals half into 5 square is 25 over 2. Do you agree with me? C is 25 over 2. Shall we input the c value back into the main equation? You find the c and you have to input the c value back into the main equation. Are you with me? So what do I get here? Substitute the c value back. What do we get? Half v square equals 2x plus 1 over 4x square plus the c value is 25 over 2. Okay, so you can see I have got the complete equation now. Is this part we are supposed to find? No, they ask us to find v square in terms of x. How do I get v square? I need to remove the half. How do I remove the half here? Multiply the whole equation by 2. If you multiply the whole equation by 2, you can get rid of the half. So what do we get here? V square equals half into 2 is 4x. So 2 into 1 over 4 is half x square. 25 over 2 into 2 into this 2 is 25. So I get v square equals 4x plus half x square plus 25. So you can see I have the complete equation where I have v square with respect to x. They're asking me to find v square, right? So find v square in terms of x. So this is v square in terms of x. Okay. So as you can see, also just to give you a heads up about the other equation that we have. So you do realize that the other equation they've given us is, now we could even use d by dx of half v square. Actually, you can see that I end up getting the half v square when I integrate, right? Can you see when I integrate the v dv, I do get the half v square. Okay, so even if you use instead of acceleration d by dx of half v square, you can still end up getting this same equation. Okay, you can still end up getting this same equation. So over here, if I write just to show you, acceleration is equal to, now the equation was, okay, I'm not doing the whole thing, just showing you how to start it. Okay, acceleration is 2 plus half x. So acceleration is what? D by dx of half v square, right? D by dx of half v square equal 2 plus half x. So once you come to this point, what we do is we integrate both the sides. Okay, so actually I prefer to use this other method in respect to this. But anyway, if you go with this, d by dx means you are supposed to differentiate, right? D by dx means differentiate, and this is integrate. So when you differentiate something and integrate the same thing, what happens? When you differentiate a person and integrate that same person, you come back to the original person, which is what? Half v square. So basically the same thing again. And the other side, when you integrate with respect to x, it's 2x plus half x square, and you have to remember to put the plus c. You end up getting the same thing. The same thing. So basically, we'll go with this. I prefer going with this, but if you want half x square over 2 here, yeah, half x square over 2 here. So actually, you could go with this or with this. So anything you prefer, both equations are correct. Okay. Okay, so we'll go to question number 2. A particle P moves along a straight line when its displacement from a fixed point O on the line is x meters and its velocity v is v meters. The deceleration, can you see? The deceleration of P is 4x meters per second square. Now you know that all the models we build are for what? Acceleration, not for deceleration. So remember, deceleration is a negative acceleration, which means for question number 2, you will write acceleration equals minus 4x. And they have told you at x equals to v is 8. Find v in terms of x. So once again, I need to emphasize you what? Are you directly going to now we know that now in the first part of the lesson, we learned acceleration. When you integrate, you get velocity. So are you going to just directly integrate acceleration and just put velocity like that here? Definitely no, this is wrong. We don't put acceleration to integrate and directly put velocity. That is correct if it is with respect to time. That is okay if it is with respect to time actually. Okay. So that will not work when acceleration is with respect to displacement. Please do not integrate acceleration directly and just write integration of acceleration is velocity when your acceleration is with respect to displacement. Okay. So this is completely wrong. So you need to stop doing that. Directly stop. This is only correct if acceleration is a function of time, then this is okay. But not when acceleration is a function of displacement. Do not do that. So what do we do then? So when acceleration, you can see here, acceleration is a function of displacement, means we have a special equation devised specially for this particular problem. Okay, so we have an equation that is devised specially for this problem. What is the equation that we devised? When acceleration is a function of displacement, the equation that we came up is acceleration equals to what? V dv by dx. This is the equation, or it's equal to d by dx of half v square. So there are two equations that we came up with. So you can use one of the two. You can use one of the two, and you have to use one of the two. You must use one of these two equations. You cannot do it independently. Are you with me? Okay, so then I will go with v dv by dx. So instead of acceleration, I will use v dv by dx is equal to minus 4x. Are you with me? Okay, so now in this particular case, when we are trying to go for velocity, we are going to perform an integration. So when you are performing an integration, the next thing we do is this dv by dx, we will break the dv by dx. Okay, so like in the earlier question, you have to break the dd by dx into the parts where I take the dx onto the side with x. Okay, so I'll take the dx over here to the other side. I get here v dv equals minus 4x times dx. Are you with me? And then you apply the integral sign. So this integral sign tells you here that the the left side is integrating with respect to v, while the right side is integrating with respect to x. So then I get here, when you integrate v with respect to with v, what do I get here? V square over 2 equals minus 4. When you integrate x with respect to x, you get x, you add 1 to the power, x to the power 1, adding 1, x square over 2. Okay, so this is v to the power 1 with respect to v, it's v square over 2 minus 4x to the power 1. When you integrate, it's 4x square over 2. And don't forget, when you integrate, you must put plus c. And now to find plus c, actually they have given you some boundary conditions. What is it? When x is 2, v is 8. So x equals 2, v equals 8. Let's put those values. So 8 square over 2 equals minus 4 into x is 2, right? 2 square over 2 plus c. 8 square is 64. 64 divided by 2 is 32. Minus 4 into 2 square divided by 2. That gives me minus 8 plus c. How much is c then? 32 plus 8 is 40. So this is the equation relating v. This is the value of c. Input the c value back into the main equation and make v the subject. So you have to input this c value back into this equation. So I get here v square over 2 equals minus 4x square over 2. Actually, we can cut the 4 and 2. Plus c is 40. Okay, and the thing is, they are asking us to get v in terms of x, right? Yeah, find v in terms of x. So first thing is to get v in terms of x. You can see I have v square over 2. Shall I get rid of the 2? The divide by 2. So I'll multiply the whole equation by 2 to get rid of the 2. So what do I get here? V square equals, when I multiply this with 2, minus 4x square, the 2 cancels out, plus 40 into 2 is 80. So this is the equation. So they want you to find v, which means what? Square root. So v is equal to square root of minus 4x square plus 80. You cannot apply the root individually to each person. The root, you have to apply to the whole equation immediately. Root of minus 4x square plus 80. Normally, when you put a root, you could also put plus or minus, because these are the plus minus. You can use it here because velocity minus means you move to the negative direction. So you do have positive negative directions here. Therefore, velocity can be negative. So you can use plus minus over here. Okay, is this clear? So this is the final answer for velocity in terms of x. Question number 4. A particle P moves along a straight line. When its displacement from a fixed point O on the line is x meters and its velocity is v meters per second in the direction of x increasing, the acceleration of P is of magnitude 25x meter per second square and is directed towards the origin. Okay. So I think we did not come across any question where we saw this kind of a word, right? Did we? No. Now, what are they saying again? The particle is moving along a straight line. Its displacement is measured from the fixed origin, no. Okay, and its velocity is v and direction of x is increasing. Now the last part, look at this section. The acceleration of p is of magnitude 25x. The magnitude is given to you 25x and is directed towards O. Okay, when you say it's directed towards O, there's something really important here. I was mentioning this in the previous section as well, I think. So when you are directing towards another thing is, we are always talking about what? Moving towards the origin or moving away from the origin. We are talking about moving away from the origin. So if they say the acceleration is towards the origin, what does it mean to you? The acceleration is towards means you must use acceleration is negative, because normally we are supposed to have it moving away. Okay, the object is supposed to move away. The acceleration is pointed, it's supposed to be away. That is positive. So we consider the positive direction of acceleration is away from the origin. So towards the origin means it is directly negative. So acceleration is minus 25x. So this is the thing that you need to, the first thing you have to realize here is this. Okay. Okay, so then let's go for acceleration with respect to displacement. So you know that you don't just use any equation. You have a very specific equation to go with when acceleration is with respect to displacement. What's the equation we go with? Acceleration is v dv by dx, isn't it? Acceleration is v dv by dx equals minus 25x. Next thing that you're supposed to do is separate variables where you take dx to the other side. So here v times dv equals minus 25x times dx, and then let's integrate both the sides. So left side integrates with respect to v, right side integrates with respect to x. So when we integrate v, I get v to the power 1. When you integrate, add 1 to the power, divide. So v to the power 2 divide by 2. In the other side, integrating minus 25x with respect to x gives me minus 25x square over 2. And then don't forget the plus c. You must put the plus c. And then to find plus c, they have given you the boundary conditions that x equals 0, v is 40. So input the value. When x is 0, v is 40. Let's get the c value. 40 square over 2 equals minus 25 into 0 square over 2 plus c. What is 40 square divided by 2? 40 square is 1600, right? 1600 divided by 2 is 800 equals 25 into 0 square. Basically multiply anything with 0, dividing with this, it's entirely 0. Plus c. So I get c equals 800. Okay, so let's input the c value. I get here v square over 2 equals minus 25x square over 2 plus c is 800. So what am I actually supposed to do here? They're saying in its motion, P is instantaneously at rest at 2 points. Okay. What are they saying? In its motion where you have this velocity, I got the velocity with respect to displacement. They're saying in this particular motion, the particle is instantaneously at rest at 2 points, A and B. Find the distance between A and B. So when you add instantaneous rest, what happens? When you add instantaneous rest, what's happening? Instantaneous rest means velocity will be 0. So instantaneous rest. Okay, you could actually make before you go to use velocity 0, if you want, you could, fix this equation because we normally prefer to see the v square subjected. So shall I just make v square the subject here to make it look better? So I get here v square equals minus 25x square when I multiply with 2 plus 1600. Are you with me? Okay, so then when you are instantaneously at rest, what happens? When you are instantaneously at rest means velocity is 0. So input velocity 0, v square becomes 0, minus 25x square plus 1600. I'll bring the minus 25x square to the other side as plus 25x square equals 1600. So I get here x square equals 1600 divided by 25. How much is it? 64. So I get x equals root 64. Remember, when you're putting the root, you can put plus or minus because they do tell us that there are 2 places. The question says there are 2 points where you add instantaneous rest. So what are the 2 places? Plus 8 and minus 8. So these are the 2 places where the particle is at instantaneous rest. So the 2 points A and B, right? So basically, what do you mean by plus 8 and minus 8? You are measuring the displacement from the origin. So from the origin O, a displacement of plus 8 is you are moving to the power, you are moving this way, away from the origin. Minus means it's to the other direction. So basically, what's the distance between the 2 points? They're asking you to find the distance between the 2 points A and B. So A is this over here. B could be the minus 8 over here. The distance between A and B is 16. So distance between A and B is equal to 16 meters. Is this clear? Okay, so this is the answer for question number 4. Okay, so again in the same exercise, let's go to the last two questions, 11 and 12. Shall we? Okay, let's go to question number 11 and 12. Yeah, we'll go to question 11 first. A particle P is moving along the x-axis. Initially, P is at the origin O, moving with velocity 15 meters per second in the direction of x increasing. Okay, initially means what? Initially means definitely time factor is 0. Initially, particle is at the origin means x displacement is 0. And the velocity is 15 meters per second in the direction of x increasing means it's a positive velocity. Okay. When the displacement of P from O is x meters, its acceleration is of magnitude 10 plus 1 over 4x, right? Its acceleration is of magnitude 10 plus 1 over 4x meter per second square in the direction of, guys, look at this, 10 plus 1 over 4x meter per second square. What is this? Directed towards O. So when you see it's directed towards O, immediately what does it tell you? Immediately, what does this tell you? The acceleration is negative. The acceleration is negative. Directed towards O means negative because away, directing away from the origin is positive. Okay. So that is the norm that you have to use here. Directed towards O is negative. Directed away from origin is positive. So find the distance P moves before first coming to instantaneous rest. So we have to find the distance that P moves before first coming to instantaneous rest. Okay. So before we do that, first thing is, to get the distance, we'll have to definitely go for the velocity, because coming to instantaneous rest means what? The moment you see the word instantaneous rest means what becomes 0? Velocity becomes 0. So obviously to get velocity 0, I'll have to get the equation that relates velocity and acceleration. So I have to come there. So how do I come there? Can I just say acceleration integration is velocity and just directly go like that? No, you know, when the acceleration is a function of displacement, there is a special equation specially devised for this instance. So what is it? For acceleration, we have to go with, in these kinds of situations where acceleration is a function of displacement, you will go acceleration is v dv by dx, or you could go with d by dx of half v square. Any of these two equations, you have to go with one of these two. So I will go with v dv by dx for acceleration equals minus 10 plus 1 over 4x. Are you with me? Okay, so then let's take the dx to the other side. V dv equals minus 10 plus 1 over 4x times dx. Do you agree with me? Okay, so then after you separate the variables, you can see d with dv, the x term is with dx. So I will integrate both the sides. So integration of the left hand side happens with respect to v. Integration of the right side happens with respect to x. So when I integrate v with respect to v, we get v square over 2. On the other side, minus, the minus mark is out, leave it out. 10 integration is 10x. 1 over 4x integration is x square over 2. Are you with me? And then don't forget the plus c. So I get here v square over 2 equals, and I open the bracket, minus 10x. I'll open the bracket with the negative, minus 10x minus 1 over 8x square plus c. Okay, so we could go for the, I mean, if you want, you could just multiply the whole equation with 2, but you'll get 2c here. That's fine. Or else just leave it like this and we'll go for our limits. What are our limits? When time is 0, x is 0, v is 15. So we can go for x0, v is 15. X is 0, v is 15. Substitute the values. What do we get here? V is 15 square, that's v square over 2, 15 square over 2 equals minus 10 into 0 is a 0, minus 1 over 8 into 0 square is a 0, plus c. Can I know the value of c? 15 square over 2 is 225 over 2 equals to c. So then input the c value back into the main equation, and I end up getting v square over 2 equals minus 10x minus 1 over 8x squares plus c is 225 over 2. And then what you do is, I prefer to keep my equation nicely with only the v square here. I'll remove the division by 2 by multiplying everyone by 2. So I get here v square equals minus 10x minus 1 over 8x square. Sorry, I'm multiplying everyone by 2. So is it minus 10x? minus 20x minus 1 over 8 into 2 is minus 1 over 4x square. 225 over 2 into 2 is 225. Okay, so this is the v square equation. Okay, and then what are we supposed to do? Actually, they are asking us find the distance p moves before first coming to instantaneous rest. So find the distance it moves before it comes to instantaneous rest, in the sense make v 0. So making v 0 minus 20x minus 1 over 4x square plus 225. Then you can see it's a quadratic equation. You have to solve the quadratic equation and get, I think you'll get 2x values, isn't it? Because there it's a quadratic equation. Solve it, get the 2x values. So I'll make it a proper quadratic equation by multiplying everyone with what? There's a 4, 1 over 4. I'll multiply everyone with a 4. And since it's a minus 1 over 4 x square, shall I multiply with a minus 4 to make it a positive x square coefficient? Because I would prefer to see my x square coefficient positive. So then I get here 0 into minus 4 is 0. Minus 20 into minus 4 is plus 80x. Minus 1 over 4 into minus is plus x square. 225 into minus 4 is minus 900. 0 equals x square, rearranging plus 80x minus 900. So now you can easily factorize. So typing in the cal, you can get the two factors. What are they? X minus 10, x plus 90. So you get two factors, x minus 10, x plus 90, making each bracket equal to 0. We get x equals 10 or x equals minus 90. So you get two x values, right? What are they actually asking us? They're asking you to find the distance p moves before first coming to instantaneous rest. Okay, find the distance p moves before first, because they, you can see they mention the word before first coming to instantaneous rest, because there might be other places also where you come to instantaneous rest. Now, according to what I got here, it comes to instantaneous rest at two places, when displacement is 10 and when displacement is minus 90. But they say when it first comes to instantaneous rest. Now the question is, how do we determine where it first comes to instantaneous rest? Is it at x equals 10 or is it at x equal minus 90? How do we determine where it first comes to instantaneous rest? So that actually you can tell it from the question. How? The question says at the beginning, the acceleration is of this magnitude in the direction of x increasing, right? The particle is moving along the x-axis. Oh, sorry, I'm looking at the wrong question. They say here the particle is moving along the x-axis. Initially, particle is at the origin moving with velocity 15 meters per second. Look at this. What? Initially particle is at the origin moving with velocity 15 meters per second in the direction of x increasing. Can you see? So particle is initially moving in the direction of x increasing, but however, the acceleration is directed towards the origin. So because the acceleration is directed towards the origin, it is moving in the direction of x increasing, but because the acceleration is to the other side, it is probably moving forward with what? With a deceleration. Because the acceleration doesn't support the direction it's moving. So it will probably go forward with a deceleration and then come to instantaneous rest and again start coming back and then go back. So that's what's happening here. Okay. So basically, what does that tell you about the displacement? Now, which displacement, which x value should I take? Whereas the first time it comes to instantaneous rest. X is 10 or x is minus 90? X is plus 10, because I know at the beginning the particle was definitely moving in the positive x direction. So therefore, it has to first come to rest when x is a positive displacement value. Okay, so you can say initially particle is moving in the direction of x increase. So you have to give your reasons here. You do not just write the answer, but give a proper reason. So you can say initially particle is moving. Initially particle is moving in the direction of x increasing. So what does it mean? It means the particle first reaches a displacement of positive 10 or negative 90. If it is moving at the direction of x increasing, therefore it reaches x equals 10 before it goes to minus 90. Okay. So therefore the first time the particle comes to instantaneous rest is at 10 meters. particle reaches x equals 10. X equals 10 before the before x equals -9. Okay, and then answer according to the question. What are they asking the question? Find the distance p moves before first coming to instantaneous rest. Therefore, p moves 10 meters before first coming to instantaneous rest. So you have to give some kind of an explanation here. Okay. The displacement -90 is also possible value, but because of the direction the particle is initially moving, it reaches the 10-meter displacement first before reaching the -90 displacement. Therefore, the first time it comes instantaneous rest is at 10 meters. Okay.